Hi, everyone. Thank you very much for staying. My name is Igal. Today I'm going to be talking to you about building IntelliJ plugins in Scala. So a slightly different topic than what you've seen so far. However, not too much, because I am going to talk to you about my experience building a plugin that helps IntelliJ understand Zio a little bit better. So before starting, I would like to introduce myself. So my name is Igal Tabachnik. I'm a software developer and recently a consultant based in Israel. I've been working in Scala for the past 4 years and doing functional programming, and I really like it. And before that, I was a .NET developer, and I was working primarily with development tools. I was building things like debuggers and plugins into various IDEs like Visual Studio. So this notion of productivity tools is something that's very close to my heart. I really enjoy the aspect of having an automated tool that helps me correct some of the mistakes I make all the time. We as developers make a lot of mistakes, and I really like when there's some automation that helps me out when something can be done about it. And so because of that, I also wanted to write something that makes Zio a little bit easier to use for newcomers. So I created the Zio IntelliJ plugin. I'm going to talk a little bit about it shortly. And finally, if you want to shout at me or ask me anything, I'm HMEM CPY, HMEM on Twitter and everywhere else. So please feel free to reach out. And let's get started. So what I would like to talk to you about today is mainly why do we want to create plugins in the first place? Then I want to quickly demonstrate some of the things that the IntelliJ platform provides us with regards to extensibility and things that we can extend. And finally, I'm just going to jump straight into coding because most of this talk is code-based. And so if you have questions, please feel free to ask them. I will try to answer them as best as I can. Let me make sure. Yeah. So right. So let's talk about why plugins in the first place. Right. So we as developers use many frameworks and libraries. Sometimes when we need to get started, we often go to the documentation or the README and maybe try a snippet or two. But the problem is that our tooling doesn't necessarily know all those libraries and frameworks. We are often just need to, it often will provide just the basic support, making sure everything compiles. But it would be nice if the framework, if the IDE that we use be a little bit smart about it and could offer us suggestions for, just getting started. So things like preventing routine errors or usage problems, like we forget to wire up something or forget to call some method. It would be nice if the tool could provide us with this knowledge for our specific framework. Another thing a tool can do, an IDE can do, is automate some repetitive tasks. So if you have if you're not necessarily doing functional programming, but you have to deal a lot with things that have to generate code and generate boilerplate, a tool can automate that process. In addition, it can help you deal with things like migrating between API versions. So if you have a deprecated API and you want to move your users to a new version, you can automate that using some rules that you can just rewrite APIs to the new version, converting as necessary. And tooling support can also help you discover better APIs. So for example, if you're following specific pattern, you might find out that there's a better way or there's a more concise way of doing the same thing. So a tool can suggest you to do that. And finally, especially with regards to IntelliJ, it's a bit of a challenge because it's not particularly easy, and sometimes it's not really documented what you want to do. So it's like an adventure. You go and you have to kind of reverse engineer your way around until you're able to find what you're looking for. But the result is very satisfying. You're able to create something that you can then ship to many people that use the IDE, and then they'll be able to enjoy, the fruits of your labor. So I put some screenshots of the Zio plugin if you've never seen it before. So the things it can offer you, it extends IntelliJ in ways that will allow you, for example, to run any specific test from the IntelliJ itself, just from the IDE, and show you the results inside the IDE. You can use things like choose a more specific type alias. You know that Zio as a library has many type aliases for the Zio type. So you can help narrow it down, make it more specific. And it also detects common usage errors. So for example, if you want to interact with the future, and here you will just mistakenly wrap it in Zio, this is not exactly going to work. So you should probably use the more specific Zio from future combinator. So this is just some of the things tooling can offer you that the compiler cannot. The compiler just does not understand the specific semantics of the library, and additional tooling can help you with that. So let's briefly talk about the IntelliJ platform. So IntelliJ is a commercial product from JetBrains. So this is not a sponsored talk. I wanted to mention that, but the offering, the commercial product itself is based on open source foundations. So IntelliJ is also still kind of a very popular choice among Scala developers, and it is a huge code base. It's fairly old. It's written mostly in Java and Kotlin, so it's very imperative in nature. But the thing about it is that everything in IntelliJ is a plugin. So all the functionalities are just plugins that the IntelliJ itself builds upon. So you start with something that's very basic, the IntelliJ platforms that provide you with some basic services. On top of that, they build the open source IntelliJ commercial IntelliJ Community Edition that provides support for Java and Kotlin and Groovy and other languages. And all the rest, and the commercial offerings, the Ultimate Editions and other products are built on top of that. So they add specific functionality. What this means is that the IntelliJ, the platform itself, is very extensible. IntelliJ exposes extension points that the plugins can implement. And everything else is just needs to implement and expose their own extension points. So for example, Scala support in IntelliJ is also a plugin, which it comes bundled with the installation, but you can always turn it off and uninstall it if you really wanted to. And so the important thing here is that plugins can depend on other plugins. And this is a fact that we're going to use very shortly, because to support the Scala language, I'm going to need the Scala plugin available in IntelliJ. Finally, it has fairly decent documentation because the platform itself, like I mentioned, it's somewhat old, and things are documented not as well as I would like. There are many things that are still missing, but if you want to kind of get started and get the feel around the things you can extend, you can find decent documentation on the JetBrains website. And I'll leave some links to the things that you can go and read if you want to at the end of this talk. Right? So before continuing, let's talk about some key features that IntelliJ offers us. We're not going to be mentioning them in detail right now, but the things that the IDE can provide you with is things like implementing your own components. So for example, you want to integrate a service or a third-party tool that crunches some data and want to make this available to rest of the components, you can do that. You can deal with things like virtual file systems. So you not necessarily have to have real files in your project model. You can create virtual nodes and interact with that. There's this whole language support called the PSI, or the Program Structure Interface, which we're going to cover in more detail. And you can extend the code editor to provide your own widgets and your own syntax highlighting if you want. You can implement code generators and many more things. All of these extension points are available to you. So today we're going to focus just on this language support, the PSI. And if you haven't heard the name, so let's briefly talk about this. And my camera is flickering. I have no idea why. I'm going to just try and stop video for a second. Okay, maybe this is better. Right. So PSI. So PSI stands for Program Structure Interface, and this is kind of the core, the heart of what IntelliJ does. This is the IntelliJ's representation of your program structure. Every code file in your system, in your project, gets translated to this PSI model. And this PSI model contains several things. It contains the syntax trees. Well, my camera is flickering, so I'm going to turn off the video so it doesn't bother you too much. Right. So the program structure interface, as I mentioned, it provides you with several things with regards to the code files. It can show you the code files. It understands the syntax of the code files. So it provides you with things like syntax trees. And also it provides you with semantic information. Once it's done figuring out what every character in your code means, it ascribes some meaning to it. So the things that are, it understands what things are types, what things are variables, what things are method names, etc. And everything, a PSI is like a base abstraction that everything is built upon. So you have at the root, you have something that's called a PSI element, which is this abstract representation. And at the very top, you have something like a PSI file, which contains trees and subtrees of these PSI elements. And this is what forms your programs, your code files. And this is how IntelliJ understands them. We're going to see exactly how to use it in just a moment. And so the most important is that the language implements its own PSI to supplement the syntax. So here we can see that the PSI model has some basic elements that all the languages share, like things like PSI whitespace that represents a single whitespace in your code, things like classes, methods, and fields for Java-like languages, and they would contain the things that you would expect. So for example, PSI class contains the name of the class, the visibility, some modifiers, and things that you would expect to be on the class level. And you can query that information and interact with it the way that you want. And the Scala plugin extends this model with additional things that are Scala specific. So they will start with the letters SC for Scala. So it adds additional things like traits and parameters types and expressions and functions and things like that, which we're going to be using very, very shortly. This screenshot here is a tool that comes with, when you start developing plugins, you get access to something that's called an internal mode. And internal mode in IntelliJ offers you additional tools that help you develop plugins. So this screenshot is of a window that we're going to use that shows you what your source code looks like from the perspective of IntelliJ. It will show you all of the elements as this PSI tree. And this becomes very important because our goal will be to look for specific elements in this tree and somehow interact with them. All right. So with this, I'm just going to go straight into IntelliJ, and hopefully, and what we will do is we'll try to implement a very basic plugin that inspects and provides some helpers on top of existing Zio projects. All right. So to get started, I've already done this because to get started it takes a few minutes. What you need to do is you need to create an empty SBT, a new SBT project essentially. And what you need to do is you need to add two things to it. You need to add the plugin. I hope everybody can see the screen. So you need to add the SBT plugin for SBT IDEA plugin. Everything is a plugin. So the SBT IDEA plugin is an SBT plugin that JetBrains developed, which will allow you to develop IntelliJ plugins from your SBT projects. You don't need to use Gradle or stuff like that anymore. So we need to add this to our plugins SBT. And in the build SBT, we need to define a few things that most of them are optional because there are sensible defaults. But what we have here is we need to give our plugin a name. So just anything will suffice. We can actually specify what version of IntelliJ our plugin will target. So here I'm targeting anything from IntelliJ community and up, so it will be supported in all of the editions. I don't have to specify this because this is the default, but if I wanted to constrain my plugin, for example, to just the Ultimate Edition, I could do that, or I could specify any specific, if I were developing a plugin for, let's say, Ruby, I could specify this only to be RubyMine, another IntelliJ, another JetBrains product, and our plugin will be only installable in that specific ID. Here I specify the minimum supported ID version, so 2020.1. And finally, this is just the project definition, and I'm here I'm saying that I'm going to depend on the Scala plugin. So I want this plugin to be installed and available to me as a dependency because I'm going to use some functionality from it. And finally, this line helps to create this run action, which would basically allow me to run the plugin as just a Java application, and I can debug it if I wanted to and just inspect it and whatnot. So this is one thing you need to do. You need to add the build SBT things. And those things come from the build SBT plugin. And finally, the other thing that you must include is this resource file called plugin XML. The plugin XML file is what makes IntelliJ understand that this is a plugin. This contains all the metadata and all of the kind of all of your extensions and things that you're going to be building. You have to specify in this plugin XML file. And you see that it has a thing like an ID and a name, and you see this name has a squiggly because the IntelliJ helps you here fill the information correctly. So for some reason they don't allow the word plugin to appear in the name of the plugin itself. This does not prevent you from compiling, but I think if you're going to publish it, that they will reject your plugin if it has the word plugin in it for some reason. You can add things like description. So this supports HTML, so you can include links and stuff like that. This says the range of the supported versions. So this is the internal version number. So it supports everything from 2020 until 2020.1 to 2020.2, all of the subversions included. This specifies the dependencies that we need. So we're stating that we're depending on the Scala plugin. And finally, this is the list of the extension points that we're going to implement, and going to come back to this shortly. So now with this just basic bare bones structure, let me just run it and see what happens. So I'm just going to run the project. And what happens is, the first time, right, so let's pick this up. So now that our plugin is installed, all right, let's do something about it. So, but first, let's open this little demo project that I've created. This is just a kind of a canonical hello world application in Zio. You've seen this before. And in fact, I'm using the Zio release candidate 20 that was released a couple of days ago, and they changed the exit code, which used to be an integer. Now it's a type called exit code. And it broke a little bit of my demos, but actually it got me an opportunity to do something better. So here we can see this is just a canonical application. So what could our plugin offer us in support for this application? Well, to run it, as you can see, we have like a hello world app, and to run it, what we do is we need to convert this return value, which is unit in this case, to something of type exit code, right? So any Scala developer, even not very familiar with Zio, can think that this is a mapping operation, right? So we want to map the return value of this program into the exit code type. So what we can do is we can do, for example, program.map, discarding the result, and just mapping it to an exit code success, right? This is a completely reasonable thing to do. You can do this. This is completely fine. It's going to work. Let's just run this really quickly. See, enter your name, Igal. Nice to meet you, Igal. So this works. However, there's a slightly better way of doing this, because what we're doing here, we're actually mapping, and we need to provide a function and discarding the result of this function. So we're actually allocating a lambda here. There's a slightly better API to do this in Zio. That we can say, instead of mapping and then providing a function, we can just say as, and removing the lambda, right? So we can say, return, treat this program as exit code, right? And this is slightly better. Just see. This is slightly better than what we had before, but it would be nice if IntelliJ could offer us a way to do this automatically. So let's see what would it take to turn this map with the lambda into as. So for this, we need to understand how IntelliJ sees the code. And for this, we need to go to this tools option. And in the sandboxed IntelliJ, we have a couple of new menus here that not usually present on your IntelliJ without internal mode. And one of them here says view PSI structure of current file, which is a very powerful tool. It will open the window and show you the code and show you the code. However, it will also show you all of the elements of the code as these three nodes here. This is the PSI tree, which I mentioned, which I talked about earlier, this is what allows you to basically, this is how IntelliJ understands your code. Every single token, every single element of your file, including things like white spaces, including things like, let's see, object. So what we have here is something that's an object, and an object has an identifier, and an object has, let's see, a space between it, and it has an identifier, and it has an extends block. And everything you can see, IntelliJ understands as a type, as something that is a part of the PSI tree, right? So here's what we want to do. What we want to do is we want to find this element, the map function, and we want to convert it to another element. Essentially, a quick fix will replace some nodes in the PSI tree with some other nodes. This is how most quick fixes that replace code work in IntelliJ. So here's what we need to do. Let's double click this map. And we'll see we'll land somewhere here in a thing that's called a method call. So this entire thing, as far as IntelliJ is concerned, is something that's called a method call. And this method call has some parts in it. So what we want to do is we want to write some sort of an inspection that would look for this expression, all right? Try to figure out that it contains a map. And inside this map, it contains a lambda. And inside this lambda, it contains a lambda that discards its argument and gives us back some body. And so we want to take this body of the lambda and convert it into an as, all right? So this is our game plan. So what we're going to do is we're going to somehow find this element, right? Find this expression. We're going to see that it matches it matches what we want to find, the map and the lambda inside. And we're going to take the body of this lambda and we're going to rewrite it into as. So for this, I'm going to close these things for now. And in order to do this, I'm going to use a little bit of a shortcut because we don't have a lot of time. And so what we need to do is we need to create something that's called an inspection. And I prepared some stubs for this. And so what we can do is we can take a little bit of a shortcut. IntelliJ has inspections for many collections and collection-like things. If you ever used, like, for example, a list, and then on the list you did a map followed by a flatten, IntelliJ would suggest you to convert it to a flat map because it can analyze functions on the list and offer you some suggestions. But it also works on things that are list-like. So for example, it works on options and iders and stuff like that. Because if you think about it, an option or an either is a list-like. An option is a list that may or may not contain a value. So what we can do here is we can use this type of inspection and say that Zio is also a type of a list, because while it might not be technically a list, it has all the semantics of a list. It has all the operations that you would expect on a list-like object. So what we can do here is we can create an inspection. I will call it simplify map inspection, which extends this type from IntelliJ called operation on collection inspection. We need to tell it that our collection-like classes come from this package, Zio underscore. And here I need to provide the simplification types. And this is the actual actions that will be applied to the matching elements in the PSI tree that will do some actual work. So this simplification, I called it as simplification. And what I want to do is if we match an element that we're looking for, I want to be able to replace it with as. This is the text that will appear on the quick fix. So here's how I'm going to do this. And this is kind of the part which is most important. I need to pattern match on this expression that I'm given. And this can be any kind of expression from the PSI tree. I don't know what it is, but what I want to do is I want to pattern match on it in order to extract some information out of it to see whether it matches what I'm looking for. So let's remind what is it that I'm looking for exactly. I'm looking for some, it's called a qualifier. I'm looking for some qualifier expression. I will explain what this means in a second, followed by a map. And so this map takes in a lambda, but a lambda that has a special shape. It's a lambda that has a single parameter, and it discards of its value and gives me back some value. And so what I want to extract is I want to extract this value. All right, just quickly check if there are right. So people wanted to see the imports. The imports are just some things internal to the plugin, and yeah, this is just to simplify the the coding experience. So what is this qualifier? Well, a map is an invocation on something, on a value of some sort. So what I don't really care in particular what the map is being invoked on. All I care about is that this is an invocation of the map method on some type that comes from a ZIO library, right? So to pattern match on this, I'm going to use some Scala trick Scala trick that might look weird initially, but bear with me. I'm going to type it out. I'm going to explain it in just a moment. So here's what I want to do. I want to take this expression and I want to match on the following thing. I want to match on any qualifier followed by a map, which is also followed by a lambda that gives me some x. And this thing can give me an x. And when I found this x, what I want to do is I want to create a replacement. Replacement is the action that the quick fix, the alt enter will perform when I invoke it. So I'm going to create a sum of replacement. I'm just going to type this out and explain this. That replaces the original expression with the qualifier and the body of the lambda that I passed here. So let's talk about this thing a bit because it might look weird, because this is standard Scala, but it uses a bit of a special syntax that I've created. So brief reminder of how pattern matching works in Scala. So in order for pattern matching to be supported on any object, there has to be two functions, apply and unapply, unapply in particular. All right. So what these things are, is I'm going to go into one of them. These are what are known as extractors. And extractors is a brilliant Scala feature that allows you to basically define any object with an unapply method. And this unapply method will take the object and will allow you to pick into it, just inspect it in some way, and optionally return some information out of that object. And this extractor will be able, you then will be able to use it in pattern matching. So what I have here is I have here a couple of, these are just the built-in, these things are coming from IntelliJ itself. So this extractor called .map, which is extractor that looks for an invocation of a map method from anything that comes from a ZIO package. This is just convenience that was provided to me by IntelliJ, and I am able to look for any .map invocation on any type that comes from the ZIO package. And if I found that, I'm going to go to another extractor. And this one, I named it like this because it helps me. This is a bit of a weird name because I'm using kind of the backticks trick from Scala to escape non-standard function names. But this kind of lets me see what is it that I'm doing. And this is an extractor that matches an expression and tries to figure out whether it's a lambda that has one single parameter. And if it has one single parameter and the name of this parameter is an underscore, then what I wanted to take is I want to take the body of this lambda and just return it in my extractor. So this is a slightly bit involved. I created those beforehand. Those things I wrote myself, but I did that in order to save some time. So when we go back to this match statement, match expression, what we can do is I can say the following: match any qualifier, anything that comes before the .map, and bind it into this value qual, followed by an invocation of .map, followed by something that has this shape, which is a lambda parameter that discards its value, and the body of the lambda, the x, will be returned from the extractor right here, so I'm able to use it. And finally, with all of these parameters, I'm going to create this replacement, which just replaces the expression with some text, and the text would be an invocation on the qualifier of a function called as, with the text of the body of the original parameter. So with this, I will run it shortly just to see what it did. But before that, also going to need to register. I'm going to enable both of them. Oops. I'm going to, in order for the IntelliJ plugin to understand that this is an extension, I have to I have to write it down here in the plugins XML. And when I do that, by the way, I immediately get this little icon, which will allow me to navigate back to the plugins XML. And this ensures that everything is wired correctly. So if you're developing extensions, make sure you see this icon. It will help you. It will help you detect whether or not things are working as they should. All right. So let me just run this and see what happens. Okay. So I'm going to open this this sandboxed instance of IntelliJ. I'm going to open our project, and now once it's loaded, here's what's going to happen. Hopefully, our map here will be. All right. Oh, of course. And I did a silly thing, and I forgot to. I have a matcher. I forgot to say that in case we cannot match for some reason or other, in case we cannot match this shape, so just continue. Just ignore and go do other stuff. So we're saying that we're focusing on a very, very specific pattern. And if this pattern is not found, I don't care about it and just continue. So when we do this, if we did everything correctly, then our map, demo gods are not with me today. Let's see, what did I forget? Let's see. Let me just quickly take a look. I have let me just quickly take a look to see if those are registered. Yeah, they're registered, they're enabled. What is it? An implementation is, oh, I'm sorry. This is what happens when you have to change your demo at the last minute. Let me just return a none here for a second. Yeah, this is from another part of the demo, which I'm hoping I will be able to make it. But yeah, I just, but at least you saw if an exception is thrown inside IntelliJ, it's not going to crash your system. It's just, they're going to catch it and show it. So here, there we go. So here, now that our inspection is actually working, well, we see that this part here, this portion of the call is painted in this ugly color. What we now can do is just hover over it, and it will tell us to replace it with as. And if we do Alt-Enter, then we can automatically now have a quick fix that rewrites this, that will rewrite this expression into as, which is great, I suppose. However, and this is a part of the breaking change, you don't even have to do this now with the exit code, because what you have is you have a function called exit code, which does this for you, right? So it would be nice if we also could rewrite this map into an exit code directly. So let me restore that exit code success. So here's how we could do this. Let's do this really quickly, and I'm going to just copy paste because why not? Of course, in the real world, we'll probably do this differently. So I'm going to name this exit code simplification, and I have to register this in the possible simplification types, just so we know that we can handle this. And I want to replace this text with replace with .exit code. This is the text that will appear on the invocation. And here, I pretty much want to do the same, except I want to check, that the body is of type exit code. And I'm going to do this simply, like I'm going to add this check here. So if I say x dot get text is equal to exit code dot success, or x get text equals to exit code dot failure. It's not the best way of doing this, but what does it scream at me? Oh, I can, of course, here, for example, IntelliJ tells me that there's a better way of doing this. So if I'm going to do, I can replace it with text matches. I guess this is a better way of checking for the name of the text. So I'm going to reformat my code. Here's what I did. I said that if the text matches exit code success or the exit code failure in the body of the lambda, then I want to rewrite this to, in fact, not this anymore. I want to rewrite it just to exit code. And now I don't need the body altogether. So I'm just going to omit this operator, right? And let's run this and see what happened. Let's quickly run this thing. And we'll start Zio, start the project. and hopefully, yeah. And now if we do alt enter, we have two replacements here. One suggesting to replace it with as, and the other that suggests to replace it with exit code, right? So this is just a tiniest thing this is just a tiny bit of functionality you can add relatively easily that would inspect existing code and provide some alternatives if you can manage to match on it, right? Now, so before we finish, actually, I want to show you another kind of thing, another functionality that actually was inspired by a blog post of a friend of mine that wrote about 5 common pitfalls when starting with Zio. And this is actually not only relevant to Zio, this is relevant to any functional library, essentially, is the fact that here, for example, this is one common mistake that you can make. You can put 2 expressions, one after the other, right? Without actually binding them together, without actually sequencing them in any way. So for example, somebody forgot to do the zip right operator here. So without this line, this expression will be completely ignored, and you will not get any warnings from the compiler. So this thing right now is dead code, because Scala has no way of knowing that this is a pure expression. This is just a method call as far as it's concerned. And it has no way of knowing that this expression is currently unused. It's used as a statement. So what we can do is we can provide some sort of inspection, some sort of analysis that tries to detect this situation. Now, what do these situations look like in with regards to Scala? What do these things look like to Scala anyway? Oops, so I'm going to open the PSI view again, and now I'm going to double click this and see that those things, those 2 method calls, are appearing as 2 sibling method calls with a white space between them, but that doesn't really matter. What we have is this situation, and this situation in functional programs is something that should not happen. We cannot have 2 method calls one after the other. What they should have between them is some sort of operator like this or flat map that binds them together. If we write it like this and do a build PSI tree, now that if I go to this, if I double tap this, I will see that these are no longer 2 sibling method calls, but they are rather wrapped in an infix expression. So this is a normal situation. However, if I remove this and do this again, I will find that I have 2 sibling method calls. Let me close this, and there I have 2 sibling method calls. So let's fix that. And I'm going to do this. I'm going to do this quickly now because we're running out of time. So here's what I want to do. I'm going to create another kind of inspection. This is a bit of a lower level inspection because I'm not matching an invocation, but I'm matching any general expression that comes from Zio. So here's what I want to do. I need to create something that's called an abstract registered inspection. This is a kind of an inspection that is general, that applies to all the elements in the tree. Here's what I need to do. Pretty similar. I need to make sure that, let me see. Let me just make sure that I'm not going to mess this up. So here's what I want to do. I want to match what I'm getting here is I'm getting any PSI element. I have no idea what it is. So what I want to do is I want to match that this element is in fact a Scala expression. So I'm going to start with matching it to be SC expression case, of course. I'm going to make sure that this is an SC expression, a Scala expression. If it's a Scala expression, so here's what I want to do. I want to capture it and its sibling node without the white space. So I can use a tuple for this. If I use a tuple or a tuple, how you say it, here's what I can do. I can capture it and optionally a next sibling not white space. This is a convenience method that the SDK provides. I can get the next sibling which is not a white space node, and I can capture them as a tuple. If both of those are SC expression, okay. And here's what I need to do. If that is the case, if I have an SC expression and the next node also is an expression, that what I want to make sure is both of them come from Zio. For this, I'm going to use another extractor which I created, which is called ZioRef. I'm going to show you it in a bit. But here's what I want to do. I want to say 0f like this. Oops. Here's what I want to say. In case I have two expressions, so this one got matched and this one optionally got matched to a sum. In case both of them come from 0, and 0f is an extractor I created, which it's a bit involved, but it peeks inside of the kinds of expression it can be and make sure that they come from 0. And to make sure that they come from 0 is just checks whether or not this is a class from the 0 package. So this is how you can check whether or not a type is from the 0 package or not. So again, let me go back to this. So if I match two expressions and both of them come from 0, then what I want to do is I want to let me just copy it from the clipboard. Here's what I want to do. I want to create some sort of inspection that's saying on the original expression, that's saying this expression is unused. Did you mean to compose it with another effect? And what I can do here is I can treat it like an unused symbol. Okay, and let me just start and show you what it looks like. But before, I need to just quit in case I haven't matched anything. So in case none of these things are matched, then I just bail out. All right, let's run this. Let's run this. And if I've done everything correctly, then what will happen is something interesting. Is I can go here to 0 playground, and now if everything worked, then this first print line, put string line right now, is faded out. And when I hover over it, it says this expression is unused. And so as soon as I fix this by binding it, for example, with the next expression like this, it becomes fully used. And when I delete this, it becomes unused again. So this already gives you a visual hint in case this happens to me often. I sometimes forget to just bind expressions together. But if you're just starting out, if you come from an imperative world, this is, I think this is one of the best things that I could come up with, just to show that the IntelliJ IDEA can help you deal with these things. And also this works. This works recursively. So this was the original snippet from the blog post of a friend of mine. They had something like this. They had the 0 when block, and inside it tried to do two values, but it failed. So if I do this, it gets fixed. However, if I forget and just let me just call, for example, program 2 here, then this entire block is going to become faded because right now this expression is unused. So if I fix it, it becomes used, and this becomes used. So you see, it works. It traverses the tree. IntelliJ traverses the PSI tree and applies it recursively to all the elements. And this feature, of course, can be used not only with 0. It can be implemented for other function libraries like cats. Everything that is expression-based and is a pure value could benefit from doing that. So with this is all that I wanted to show you with regards to how would you go and look for what is it that you want to implement and translate that back to this not too horrible looking code, but it's still not the best Scala code that can be, but it conveys intent of what you want to do. And it would be much worse in languages like Java and even Kotlin that don't have pattern matching and don't have extractors, because you would have nested ifs traversing this tree and trying to extract elements. So with this, I'm going to just conclude. I'm sorry for taking more time. So just as a summary, if you're interested in doing stuff like that, here's a bunch of things that you can look at. You have the source code for many of these things on GitHub for the Scala plugin. And if you actually want to see what a bigger plugin looks like, you can go and look at Haskforce, which is the implementation of Haskell for IntelliJ written in Scala. This is by Kerry Robbins, who also created the new type macro. So if you want to see a complete implementation of kind of an entire language support in IntelliJ, you can go and look at the source code for that. And with that, I wanted to thank you again for coming. And despite the technical difficulties we had, I hope it was at least a little bit interesting. And please let me know if you have questions, and go check out the Zio plugin for IntelliJ. It provides many, many more of these things for you. Thank you.